Let's work with OpenSSL. OpenSSL is a tool run generally from the command line for working with certificates, certificate authorities, server certificates, signatures, and so forth in a public cryptography world, although there are also private cryptographic functions that also can be used here as well. First of all, we're not going to be able to cover every aspect of OpenSSL in this particular segment. But keep in mind that OpenSSL has a built-in help system and is very well documented and is used throughout most of the internet as you know it for cryptographic functions. There is a man page for it for subcommands as well, so you can man on OpenSSL, but you can use a man page on the request, REQ, or on a particular format, like X509. So there are subcommands that can also be looked at from man pages and other things as well when working with it. The etc/ssl openssl.conf file is very useful for storing default values so that when you work with OpenSSL, it will autofill or pre-populate various fields and functions during the generation of keys and certificates. OpenSSL is frequently used to create a root certificate authority as well. Now, why would we create a certificate authority? A certificate authority gives us the ability to validate at the top level the certificate authority itself, and then anything that's down below it that comes from that certificate authority is by default accepted once the certificate authority is validated, so that we can accept any key that was created by a root CA. As a result of this, you have to be very careful with your root certificate authority to validate and make sure that it is secure at all times, because if someone gets in at the top level, they have access to revoke and cause problems down below. So, as an example of using the OpenSSL command for creating a root CA, you see the command that's on the screen. OpenSSL generated new request of X509 type, create the CA key, PEM file, create the actual certificate itself, how long is it valid for, that's the number of days, and then generate the new key with an RSA type of 4096 bits. So this is a lot of information, but if you break it down into individual parts, it is relatively easy to understand if you break down and look at what each one of those OpenSSL command functions are doing. Now, during the process, if you executed this command here, it would ask you some of the following. It would say, what's the passphrase for the CA key PEM? In other words, just because you have access to the key doesn't mean that you can do anything with it. It has a built-in safeguard that requires that you have a passphrase, similar to a password, for that certificate authority before it can be used for any task. Then, of course, you have country code, a state or province name, locality, which would be like a city, organizational name, organizational unit name, common name, which is tied to the person who's generating this, and then an email address so that issues with certificates have somewhere to go. Okay, so there's generating a root certificate authority. We're creating that top level so that we can create server keys and so forth from the root CA. So when we've created a certificate authority and we want to create a server-specific key, we create what's called a request. So OpenSSL space rec space -new, and then we specify where the key is going to be, where the request is going to be, and then the strength of the key as well, RSA 2048. Now, the common name, in order for this to work properly, needs to match the fully qualified domain name of the server. So, accounting.example.com. A problem would arise if you were to leave out that information. As an example, you generate accounting.example.com, but then you use the accounting.example.com server key and you use it for, say, marketing.example.com. And it would throw an error in the browser, if you were using a browser to attach to it, and tell you that the key doesn't match. Obviously, we want to avoid that. We can also kind of pre-fill some of the items that are listed here. So we can go into the etc OpenSSL.com file, and we can set, as an example, the default organization name, the default locality. We can set default state or province, and so forth. This becomes useful, especially when you're generating lots of different keys or going to need them. It auto-fills those for you, and then you can accept some default values, and it speeds up the process. Now, after you have sent the signing request to the CA for signing, then you can sign it yourself with your root CA. Now, what does this mean? Well, if you generate a root CA and you're going to need your website available out on the internet, and you need that website to not throw a certificate error, then you take your root CA and you send a certificate signing request, usually to a commercial body, for them to sign. There's, of course, a fee involved with this, but it makes it so that they validate that you are okay. And most browsers will already accept those commercial CAs. And since they are validating your key, you are grandfathered in, and browsers will start validating your certificates as valid as well. Now, how do we do that? Well, we create what's called an index.txt file and a serial file. These are tools that are used during the creation or signing of certificates to make sure that we are keeping track and auditing what's going on within our certificate authority. Then we sign the certificate itself by pointing at the request file that was generated here. So if you look at the bottom where it says sign the certificate, you'll notice that it says, and where's the request, that bottom line? It's saying use that request. That's the one that we want to validate. So after we've created those keys, we've signed them, we've made them valid, we then copy those server keys and cert files to the location that they're supposed to sit in. As an example, for Apache, you might put the server key under etc apache2 ssl.key and the cert key under etc apache2 ssl.cert. Now those keys will be available while you're working with, if you're going through Apache in order to access whatever that server's host name is.